I'm April, and for today's video, I will give you an explanation on what everything is made up of. So everything na nakikita niyo sa paligid natin, including tayo, is made up of matter. As we all know, matter is anything that occupies space and has mass. And matter now is made up of different types of elements. Elements, as we have discussed on the previous episode, is made up of identical atoms, and it is a pure substance that cannot be subdivided anymore via physical or chemical means. As of today, there's 118 known elements, 98 of which are naturally occurring, and the rest are made by chemists and physicists inside the laboratory. These elements can be symbolized by a single letter like C for carbon, H for hydrogen, O for oxygen, N for nitrogen, and so forth, or by two letters like Na for sodium. These names are derived from different sources. It can be named after a person. For example, we have borium. Borium is named after Niels Bohr, who proposed the theory for atomic structure. It can also be named after a geographic location like Californium. Californium is derived from the state California, kung saan siya unang nagawa. All 118 elements are arranged and highly organized in a table we call the periodic table of elements. And in my opinion, you don't have to memorize it. Ang importante is you understand it and you know how to use it. Out of these elements, 25 are essential for life. Primarily, you will encounter carbon, hydrogen, oxygen, and nitrogen because it actually comprises 96% of most living organisms. So going back, elements are made up of identical atoms. Atoms is derived from a Greek word which means not to cut or not to be divisible, because it is the smallest unit possible that still retains the property of its element. Meaning you cannot cut it or break it down into smaller pieces and still retain its identity or characteristic. For example, when you break down water down to its building block, may matitira ka pa rin dalawang hydrogen atoms and isang oxygen atom na pwede mong i-differentiate sa isa't isa. When we talk about atoms, it's usually illustrated like this. Pero sa totoong buhay, hindi ganyan talaga yung itsura niya. We only use models, illustrations as representations para mas madali natin siyang maintindihan. So let's break down an atom. So an atom has subatomic particles we call protons, neutrons, and electrons. Today, we will differentiate them in three categories: by location, charge, and relative size. Umpisahan natin sa location. An atom has a nucleus and an electron cloud. So inside the nucleus, we can see the protons and the neutrons. And on the electron clouds, we can see electrons moving freely. Next, we have charge. So for proton, P, positive charge. Neutron, we have neut for neutral because it has no charge. And lastly, we have electron, which is negatively charged. Always remember that the number of protons inside an atom is equal to the number of electrons. That's why an atom is said to be electrically neutral. Now let's move on to the last category, which is the relative size, which is expressed in atomic mass units. So as you can notice, even though neutron is slightly bigger than protons, it is actually given the same value, which is 1 atomic mass unit. On the other hand, we have electron, which is very, very, very small. It's actually 1,840 times smaller than protons and neutrons, and given the value 0.0005. Based on these values, we can actually infer that most of the atomic mass is concentrated inside the nucleus and the rest is filled with empty space. Since we have mentioned atomic mass, let's differentiate atomic number from atomic mass number, or also known as the atomic weight. So when we say atomic number, we only focus on the number of protons inside the nucleus. So for example, we have atomic number 6, which denotes carbon. So meaning a carbon atom always contains 6 protons. This number doesn't change. So what happens if I add another proton? Carbon pa rin ba yun? So instead of 6, I have 7 protons. And now, instead of carbon, we have a nitrogen atom. Next, we have the atomic mass number or atomic weight. To Gaya ng sinabi ko kanina, most of the atomic mass is concentrated inside the nucleus. Kaya, for atomic mass, we count both the number of protons and the number of neutrons. Atomic mass is usually in decimal form. Bakit kaya? Kasi even though the number of protons does not change, the number of neutrons natin is pwedeng magbago, kaya we have isotopes. So ano ba yung mga isotopes? Isotopes are atoms with the same number of protons but different number of neutrons. So we get the weighted average of these isotopes to get the mass number. So let's take carbon and complete this table. Carbon 12, carbon 13, and carbon 14. So since we have atomic number 6, which denotes the number of proton inside an atom, all of them contain 6 protons. Next, as we have said earlier, the number of protons is always equal to the number of electrons. So still, we have 6 electrons sa lahat ng isotopes. And lastly, we have neutrons. Most common carbons contain 6 neutrons inside its atom. So to get the mass number, we simply add 6 plus 6 to get 12. That's why it's called carbon 12 or C12. Some carbon contains extra neutrons, so instead of 6, we have 7 neutrons. So we simply add 6 plus 7 to get 13. That's why it's called C13 or carbon 13. And lastly, some carbon contains extra 2 neutrons. So instead of 6, we have 8. So add 6 plus 8, we have 14. That's why it's called C14 or carbon 14. Out of these isotopes, baka familiar kayo with C14 because it's used in radioactive dating. Radioactive dating is used to determine the age of a material. So kung mahilig kayo sa geographic channels, ito yung ginagamit to determine the age of the rocks, fossils, mga trees, etc. Moving on, si atom guys is parang tao din. Parang tayo, we love and strive to be stable. As a social creature, some of us needs to interact or be with other people to be happy. Pero meron ding mga tao who prefers to be alone. Ganon din sa atoms, and we call them noble gases. Hence the term noble because they don't mix with the commoners. These are inert gases, mga nag-iinerte, and they do not form bond with other atoms. So kailangan natin pag-aralan ng mabuti si electron to understand why. So electrons, as we have discussed earlier, is found sa electron cloud. Yung electron cloud natin guys ay may different energy levels or shells. And finifill ni electron yung mga shells na to from the shell na pinakamalapit sa nucleus palabas. And each shell has its maximum capacity. So for the first shell, we have 2 electrons lang. And for the second, third, and so forth, we have 8 electrons. I will make a separate video sa detailed explanation ng electron configuration. What I want you to remember is that atom is happy and stable when the outermost, or what we call the valence shell, is filled with electrons. So, isi-share ko sa inyo yung pinakamagandang analogy na na-discover ko. So, imagine a concert stadium wherein yung stage nasa gitna, which represents our nucleus, and then ito yung mga rows ng seats na ino-occupy ng audience. Itong rows ng seats na to, yung nagre-represent sa shells natin. So, we have a rule and a goal. So, yung rule natin is to sell seats closest to the stage first. So, dapat mabenta muna yung mga ticket na malapit sa stage. So, itong first row natin guys, ito yung VIP area wherein kaya niya lang mag-occupy ng 2 seats. And then yung second, third, and so forth, yung maximum capacity niya is 8 seats. So, yung goal natin is mapuno lahat ng seats sa lahat ng shell. First example is hydrogen, which is atomic number 1, which means it has 1 proton inside an atom. And sabi natin kanina kung gaano kadami yung proton, ganun din kadami yung electron. Kaya 1 proton, meron din tayong 1 electron. Sabi natin sa rule, we should occupy the seat closest to the stage first. Yung isang electron ni hydrogen is i-occupy niya yung seat na to. Question, na-reach ba natin yung goal natin? So, napuno ba natin yung shell na to ng electron? No, kasi meron pa tayong empty seat. So, si hydrogen is not stable and not happy pag mag-isa lang siya. So, the tendency, lagi siyang nakakabit sa ibang atom. So, next example, we have helium with an atomic number of 2. So, pag atomic number is 2, we have 2 protons inside an atom. So, kung meron tayong dalawang proton, ilan yung electron natin? Tama, dalawa din. Dalawang electron. Again, yung rule natin is to occupy the seats closest to the stage. So, we have 1 electron and 2 electron. Question, na-satisfy ba natin yung goal? Yes. Yung shell na to is completely filled with electrons. So, yes, helium is stable and happy. So, kung mapapansin nyo, helium is one of the noble gases or our inert gases who do not like to mix with other atoms. Another example, guys, is carbon, which has an atomic number of 6. So, atomic number of 6, we have 6 protons, and when we have 6 protons, how many electrons? Yes, we have 6 electrons. So, check natin ulit yung rule. We have to occupy the seats closest to the stage first. So, we have 1 electron, 2 electron. Since na-fill na yung first shell, pupunta na tayo sa second shell. So, 1, 2, 3, 4, 5, 6. Question, na-satisfy ba natin yung goal? No, kasi meron pa tayong 4 na empty seats. So, no, carbon is also not stable on its own, kaya usually, naka-attach din siya sa ibang atom. So, another example, we have neon, which is atomic number 10. So, atomic number 10, how many protons do we have? 10. So, if we have 10 protons, how many electrons do we have? We have also 10 electrons. So, check natin. Rule, we should occupy the seats closest to the stage. So, we have 1 electron, 2 electrons, then we'll proceed to the next shell. So, 3 electrons, 4, 5, 6, 7, 8, 9, and 10. So, question, na-satisfy ba natin yung goal? Yes, kasi kumpleto natin yung seats sa first shell and also na-fill din natin yung sa second shell. So, neon is stable and happy on its own. So, kung mapapansin nyo, neon is also part of the noble gases. Pinaka-importante talaga dito is yung outermost or what we call the valence shell. Dito rin nag-focus si Mr. Gilbert Lewis sa kanyang Lewis dot structure wherein we draw dots sa paligid ng elements to denote valence electrons. Ano yung mga valence electrons na to? Yun yung mga electrons present sa pinaka-outer shell. So, balikan natin yung mga examples natin. How many electrons for neon? We have 1, 2, 3, 4, 5, 6, 7, 8. That's why we draw the Lewis dot as 1, 2, 3, 4, 5, 6, 7, 8. So, there's also an easy way para hindi nyo na siya kailangan i-drawing. For the first shell, gaano kadami yung kayang electron? We have 2. And then, yung 10 electrons natin minus 2, ilan na lang matitira? We have 8 electrons. So, ito na yung pinaka-outer shell natin, kaya we have 8 electrons. Si carbon, which has 6 electrons. So, first shell hanggang ilan? 2. So, kung nabawas na yung 2 electrons, ilan na lang yung matitira for the second shell? We only have 4 electrons left. So, pag dinrawing natin yung Lewis dot structure ni carbon, we have 1, 2, 3, 4. Next, for the helium, sabi natin we have 2 electrons. So first shell, meron lang tayong 2 electrons, and that's it. Draw the Lewis dot structure for helium like this. 1, 2. And then lastly, we have hydrogen, wherein isa lang yung electron natin, kaya dinadraw natin siya like this. Hydrogen with 1 electron. So let's have more examples for practice. Oxygen with the atomic number of 8. Since we have atomic number 8, how many protons do we have? We have 8 protons. So if we have 8 protons, how many electrons is present? We also have 8 electrons. First shell hanggang ilan lang? 2 electrons. And ang matitira na lang is 6. Check lang natin for the last time if magko-coincide kapag ganito yung ginawa natin or pag dinrawing natin. So, rule natin is to fill the seats closest to the stage. So, we have 1, then 2, then 3, 4, 5, 6, 7, 8. So, bilangin natin yung valence electrons natin, which is yung electrons sa outermost shell. So, we have 1, 2, 3, 4, 5, 6. So, same sila. So, let's go ahead and draw the Lewis dot structure. So, oxygen, then 1, 2, 3, 4, 5, 6. So, for the next example, we have sodium with the atomic number of 11. So, atomic number of 11, we have 11 protons. So, if we have 11 protons, how many electrons do we have? Yes, we also have 11 electrons. So, for the first shell, we only have 2 electrons. And then, for the next shell, kaya natin ma-fill yung 8 electrons. And then, we'll proceed to the third shell, which ang matitira na lang is 1 electron. So, 2 plus 8 plus 1, we have 11 electrons. So, we can now go ahead and draw the Lewis dot structure for sodium, which is may isang valence electron like so. Diba? Dali lang. So, last example, we have fluorine. So, its atomic number 17. We have 17 protons. And since we have 17 protons, how many electrons do we have? Yes, we have 17 electrons. So, for the first shell, we have 2 electrons. For the second shell, we have 8 electrons. And then 2 plus 8, we have 10. Ilan na lang matitira? We have 7. So, 2 plus 8 plus 7, we have 17 electrons. And yung valence electron natin is 7. So, let's go ahead and draw the Lewis dot structure, which is 1, 2, 3, 4, 5, 6, 7. Gets? Nuggets? Nuggets? Okay. Understanding the Lewis dot structure make predicting the atomic interaction so much easier. This explains why these noble gases na meron ng complete valence electron, meaning kompleto na yung electron sa paligid ng element, which is nasatisfied na yung 8 electrons, do not need to mix with other atoms para maging stable and happy, unlike these atoms sa kaliwa. Since noble gases are happy on their own, hindi na sila nakikipag-interact with other atoms, bigyan ko kayo ng examples on how these atoms interact when we combine hydrogen and chlorine. So, hydrogen has 1 electron and chlorine has 7 valence electrons. First shell, kailangan lang niya ng 2 electrons. By forming this bond, nag-share sila ng electrons. So, let's check kung nasatisfy ba yung first shell ni hydrogen. So, for hydrogen, we have 1, 2 electrons. So, yes, nasatisfy yung first shell niya. Let's check for chlorine. So, we have 1, 2, 3, 4, 5, 6, 7, and 8. So, yes, satisfied na rin. So, we have our HCl, which is now stable and happy. Next, we have oxygen atoms. For example, yung unang electrons nila is mag-share. Okay, let's check if nasatisfy na si octet. So, we have 1, 2, 3, 4, 5, 6, 7. Satisfied na ba? Hindi pa rin. Ang goal natin is to reach 8 and 7 pa lang to. So, tendency, magpo-form pa tayo ng isang bond. Check natin if nasatisfy na. So, we have 1, 2, 3, 4, 5, 6, 7, 8. So, satisfied na yung unang oxygen natin. Let's check the other one. So, we have 1, 2, 3, 4, 5, 6, 7, 8. And yes, satisfied na rin. So, ngayon, itong oxygen molecule natin is stable and happy. Kung matatandaan nyo, oxygen molecule is an example of diatomic molecules wherein kailangan present sila ng magkasama para stable. So, our takeaway for this episode is that everything is made up of matter. Matter is anything that occupies space and has mass. Matter now is made up of different types of element. Element is a pure substance which you cannot break down anymore via physical and chemical means, and these are made up of identical atoms. Atoms is made up of subatomic particles. Inside the nucleus, we have the protons and neutrons. And in the electron cloud, makikita natin yung electrons moving freely. Sa electron cloud, we have different energy levels or what we call shells. And each shell has its maximum capacity. For the first shell, we have 2 electrons lang. For the second, third, and so forth, we have 8 electrons. Our goal to make the atom stable and happy is to make sure that the outermost shell or the valence shell is filled with electrons, just like these noble gases. These noble gases satisfy the octet rule already, that's why they don't interact with other atoms anymore. Understanding Lewis dot structure help us predict atomic interactions, just like how we make hydrochloric acid compound and the oxygen molecules. That's all for today's episode, guys. Sana may natutunan kayo or may na-clarify ako sa inyong mga bagay-bagay. So please do like, comment, and subscribe for more videos. Thank you for watching. Bye!